Starting with the chapter 3, that is what atoms and molecules. So, in ancient Greek, this chapter is very important from exam perspective. Ancient Indian and Greek philosophers have always wondered about unknown and the unseen format of matter. The idea of divisibility of matter was considered long back in India. Okay, around 500 BC, an Indian philosopher, Maharishi Kannad, or Vaishika, जो is kind of philosophy, Indian philosophy, six philosophy that's come under this Kannad. Marzi Kannad postulated that if we go on dividing matter, Padarth, we shall get smaller and smaller particles. Ultimately, a stage will come when we shall have across the smallest particles beyond which further division will not be possible. So he named these particles Parmanu, Pokhran, Parmanu movie. Okay, another Indian philosopher, Pakuda Katyayam, elaborated this doctrine and said that these particles normally exist in the combined form, which give us various form of matter. So around the same era, ancient Greek philosopher Democritus and this suggested that we go on dividing matter. A stage will come when perhaps particles obtained cannot be divided further. So call these indivisible particles atoms meaning divisible. Okay, so now Anthony L. Lavoisier laid the foundation of chemical science by establishing two important laws of chemical combination. So from here we have already been asked question. So let's see, the following two laws of chemical combination were established after much experiment by Lavoisier and Joseph L. Proust. Now, laws of conservation of mass. Okay, so is there a change in mass when chemical change, chemical reaction takes place? Okay, so laws of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. So it changes from one state to another or transfer. Now, laws of constant proportion. Lavoisier, along with other scientists, noted that many compounds were composed of two or more elements, and each such compound had the same element in the same proportion, respective of where the compound came from or who prepared it. So, in a compound such as water, the ratio of the mass of hydrogen to mass of oxygen is always 1 ratio 8. Whatever the source of water, thus, if a 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14 ratio 3 by mass. Whatever the method or the source from which it is obtained, this led to the law of constant proportion, which is also known as the law of definite proportion. So this law was stated by the Proust as in a chemical substance, the elements are always present in definite proportion by mass. So the next problem faced by the scientist was to give appropriate explanation of these laws. British chemist John Dalton provided the basic theory about the nature of the matter. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. He took the name of atom as given by the Greek and said that the smallest particle of the matter are atoms. So his theory was based on the laws of chemical combination. Dalton's systemic theory provided an explanation for the law of conservation of mass and the law of definite proportion. So here is a Dalton atomic theory, ठीक है, provided for the explanation of law of conservation of mass and law of definite proportion. No, something about John Dalton. Was born in poor weaver family, England. He began his career as a teacher at the age of 12. 7 years later, he became a school principal. 93, Dalton left for Manchester to teach mathematics, physics, and chemistry in college. He spent most of his life there teaching and researching. In 1808, he presented his atomic theory, which was turning point in the study of matter. So, from here, many of the question, since even last BPSC, one question has been asked. So all the matter is made up of very tiny particles called atom, which particles chemical reaction. So there will be something wrong with this theory, and later we will get some modification in this theory. So atoms are indivisible particles which cannot be created or destroyed in the chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine the ratio of a small whole number or to form compound. Relative number of kind of atom are constant in a given compound. So you will study next chapter. All the atoms are made up of still small particles. Now, what is an atom? So here, have you ever observed a mason building walls from these walls, a room, and then a collection of rooms from the building? What is the building block or the huge building? What about the building block or ant hill? It is a small grain of sand. Similarly, the building block of all matter are atom. So how big are atoms? Atoms are very small. They are smaller than anything we can imagine or compare with. More than millions of atoms we stacked would make a layer barely as thick as sheet of paper. Okay, so atomic radius is measured in nanometer, and 1 meter is equal to 10 to the power 9 nm. Okay, now here this is 10 to the minus 1 is apple, minus 3 is ant. Okay, and minus 4 is grain of sand. We have seen sands, 10 to minus 4, and minus 8 molecules of hemoglobin, minus 9 molecules of water, and minus 10 is atom of hydrogen. So just imagine the level of slinkness. Now an image on the surface of a silicon. See how it's appear. Might think that the atoms are so insignificant in size. Why should we care about them? This is because our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Through modern techniques, we can now produce magnified images of surface of elements showing atoms. Now, what are the modern symbols of atom different? So Dalton was the first scientist to use the symbols for element in very specific sense. When he used a symbol for element, he also meant different quantity of that element. That is one atom, that element. Now, Berzelius suggested a symbol of element be made from one or two letter of the name of the element. So these are the things. Now, for example, hydrogen H, aluminum Al, not El, cobalt and CO. So first letter capital, small, second small. So these are the symbol of some elements: aluminum Al, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C, chlorine, cobalt, copper Cu, fluorine, gold Au, hydrogen H, iodine I, iron, lead Pb, magnesium Mg, neon Ng, nitrogen, oxygen, potassium, silicon Si, silver Ez, sodium Na, sulfur, and zinc and uranium. Now, so these are the things. Atomic mass, we can see hydrogen has 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, and sulfur 32, chlorine 35.5, and 40. So here are the some other symbol of some ions, and these are formula of simple compound, formula of hydrogen chloride HCl. So here the symbol is Hc. There's one valence, so HCl would be there. Now valency H का 2 है and S has 1, so formula is S2S. Aluminium oxide का देखते हैं तो aluminium is 2 minus 2 and here is 3, so Al2 and 3O3. Similarly, Ca2O2 we simply formula as CaO. CaO is for, I think, is for quick lime. Formula for calcium oxide, so it's a calcium oxide. Two element, you arrive at the formula of this. Now formula of sodium nitrate. Sodium nitrate क्या है? NaNO3, तो 1 1, so NaNO3. COH COH2. Similarly, molecular mass. Now these are the things. So what we have learned here is during a chemical reaction, the sum of the masses of reactant and product remains unchanged. So, okay, some of the masses of the reactant products remains. This is known as law of conservation of mass. The pure chemical compound elements are always present in different proportion by mass. This is also known as law of different proportion. An atom is the smallest particles of element that cannot usually exist independently and retain all its chemical properties. A molecule is the smallest particle of an element or a compound capable of independent existence under ordinary condition. It shows all the properties of substances. A chemical formula of compound shows its constituent element and the number of atoms of each combining element. Now, cluster of atoms that act as an ion are called polyatomic ions. They carry a fixed charge on them. Now, the chemical formula of a molecular compound is determined by the valency of each element. Now, the ionic compound, the charge of each ion is used to determine the chemical formula of the compound.